This video is over lesson 33, comparing decimals and rounding decimals, and it is for my 7th grade math class. So, ladies and gentlemen, if you grab your blue highlighter, we're going to go ahead and highlight this in blue. So comparing decimal numbers by place value, I'll try to get that out of my shadow there. Sorry, my lighting's just not very good. So comparing decimal numbers by place value, and just to make this pop for later, let's go ahead and put a box around those 4 steps. So there are a couple different ways that we can compare decimals, and one is by their actual place value. So step 1, we want to rewrite the numbers vertically, lining up their decimal points. So lining up their decimal points is also going to line up all of their place values. So if I go ahead and do step 1 right here, 0.31, 0.048, 0.502, and 0.09364. And now I have provided blanks for each of the digits. And so when you're doing this without blanks, you're going to want to make sure that you're also lining up the digits. So lining up the decimals, lining up the decimals is just the first step. Lining up each digit then is the continuation of that step. All right, so step 2, the number with the largest digit in the largest place value is actually the largest number. So largest digit in the largest place value, largest number. If those digits are the same, then compare the next largest place value. Okay, so if it's a tie, move on to the next place. Continue comparing values as needed until there is a place value with a larger digit. Now, if you never come to a larger digit, then obviously those two numbers are the same. So if we take a look here, the largest place value we have here is the ones place. So grab your yellow here, and let's just highlight down the ones place there. So if we compare all these numbers by their ones place, we can see it's a 4-way tie. They're all the same as far as the ones place goes. So that's not terribly helpful. And then that means that we now need to move on to the next highest. And for that, let's grab our orange. So if we grab our orange and compare now the next largest place value, so in this case, this would be the 10th place, we can see that we have a 3, a 0, a 5, and a 1. Or excuse me, and another 0. So 3, 0, 5, 0. So 2 of these are obviously larger than the others. And then one of them obviously comes out as the largest. So this one right here with the 5 is bigger than 3 or 0. So this number right here is the largest. Now, we can also tell, though, that the 3 is larger than the zeros. So this one has to be the second largest. Now, as far as these two goes, though, in their tenths places, we can't really tell a difference between them. So for those two, to figure out which one's bigger, we're going to have to move on to now the next place. So let's grab our green for that. So I don't need to highlight the 2 that we've already determined. We already know that this one's the largest. We know that that one's the second largest. So it's just these 2 that we need to compare. And so now that we're down to the hundredths, we can see that there's a difference between these 2. And between a 4 and a 9, obviously the 9 is bigger, which means that this then is the third largest, which means that this is the fourth largest. Now let's go up to the directions for this problem. Put these decimal numbers in order from least to greatest. So once we've compared these, then obviously we can tell them that the fourth largest is actually the smallest. So 0.048 is the smallest. The third largest would be next. So I'm going to put a comma because this is a list. So 0.09364. The second largest, 0.31, and then we end with the largest, which was 0.502. And so on the homework, when we get a problem like that, we should actually write out our decimals to compare if we're using this method, and then we should go ahead and write our answer there. So like I said, there are multiple ways. I'm going to give you another way to compare these. So let's take our blue again, and we're going to make a box around these instructions. So there is a way that we can compare whole numbers compare decimals, like by treating them like whole numbers. And so step one again is to rewrite the numbers vertically, lining up the decimal points. So it's actually the same step. So for this problem, I'm going to take my 0.09, my 0.082, my 0.0905, and my 0.0082. I'm just going to line up those decimals to start. So in this one, step two though, we're going to fill in zeros so that each decimal number has the same number of decimal places. So we can see this has only got 2 decimal places, this has 3, this has 4, this has 4. So I'm just going to take these empty spaces and fill them in. Now once that's done, this becomes really easy because now all we're going to do is we're going to ignore the decimal and compare the numbers like whole numbers. So if I ignore the decimal, what do we see? Well, this decimal, if we ignore the decimal itself, this decimal number basically looks like 900. This number looks like 820. Now understand they're not, but they look like that without their decimals. This number right here looks like 905, and this decimal right here looks like 82. Now, just to be clear, this method only works if you fill in those empty spaces with zeros so that each decimal has the exact same number of decimal places. Now, looking at these, it should be pretty easy to see that 905 would be the biggest, 900 the second biggest, 820 after that, and finally smallest would be 82. Or to flip it around, we're going to write these in order from least to greatest. So the one that, if we ignore the decimal, looks like an 82 is the smallest. So 0.082 is the smallest. Next would come the one that looks like 820. So 0.8, or excuse me, I missed a 0 there, sorry. 0.082. Next would be the one that looks like 900, which was my 0.09. And then last would be my largest, 0.0905. So let's flip to the back. Often you'll be asked to compare 2 decimal numbers. And so we're going to practice these 2 methods. But instead of with 4 numbers and putting them in order, we're going to do it with just 2 and try to move a little quickly through it. So up top, let's go ahead and practice by comparing place values. And on the bottom 3 examples, we'll fill in the zeros. If we take a look at this first one, copy the problem. Now in the book, these are going to be circles. You'll have to forgive me on the computer. The best I could get with the program I was working with was boxes. But in the book, you're going to see circles where then we have to put in our comparison symbol. So if we line up our decimals, 0.702 compared to 0.72. So again, starting with the ones places, no difference. As far as the one places go, these are equal. Okay, move on, orange. The tenths place, they're both 7s, so they're still equal as far as the tenths places go. So move on now to the hundredths. All right, now they're finally different. And as you start getting used to this, obviously you're not going to do the highlighting anymore. But as you start getting used to this, you should be able to do this fairly quickly without taking a lot of extra time to think about it. It just should start coming naturally after a while. So 0 or 2, which one's bigger? Well, obviously the 2 is bigger. So I'm going to put my comparison symbol in there. So 0.702 is less than 0.72. And just a reminder on your comparison symbols, if you imagine this like an alligator mouth, you want the mouth to be eating the larger number. All right, so next example, let's say we compare 0.72 with 0.072. And if you're already getting comfortable with this, you can probably see what the answer would be right away, but just for good measure, all right, compare the ones place, that was our yellow, no difference, right? So as far as the ones place go, they're the same. Move on to the tenths though, and now we've got a difference. Now obviously, which is bigger, 7 or 0? It's the 7. So 0.72 is greater than 0.072. And then finally, in our last one, we have 0.720 compared to 0.72. So if we compare these, grab your yellow, in their ones places, they're the same, so no difference. Grab your orange now. In your tenths, we got a 7 and a 7, so no difference there. Move on now to the hundredths. 2 and a 2, that's the same. And then for this last one, let's go ahead and grab our pink. Let's grab pink for the last color there. And so we got to keep moving on then to this last place value. And so we have a comparison now between 0 and nothing. But remember, every decimal place actually is full. Every place value is full with a digit. But if you don't see that digit, it just means it's an invisible 0. So this is really a 0 compared to an invisible 0. Well, those are the same, which means these two numbers are equal. So if you get through all your place values and they're all the same, those two numbers are equal. All right, we're going to come down here now and we're going to practice the other method. So the method here of filling in all the extra 0 spaces. So we have 0.45 compared to 4.5. So if we are lining up our digits and our decimals, then you can see that there should be an extra 0 filled in here. So if you just pretend like that decimal's not there, this is like comparing 45 to 450. Well, obviously, what's bigger? The one that looks like a 450. So 4.5 must be greater. All right, next one, 0.628 compared to 0.6233. We can obviously see there's going to be a 0 fill in here. So if I ignore that decimal, that top number looks like 6,280 versus the bottom number looks like 6,233. Well, they both have 6,200, so which one's bigger, the 80 or the 33? Well, obviously the 80 is bigger, so it's the 0.628 that's larger than, greater than 0.6233. And then for our final example, 8.190 compared to 8.200. That one already has same number of decimal places, so really just as a matter of compare. So without the decimal, this looks like 8,190 compared to 8,200. Well, they both look like an 8,000, so which is bigger, 190 or 200? Well, obviously 200 is bigger. So this would be a greater than, or excuse me, less than. 8.190 is less than 8.200. And now, ladies and gentlemen, to finish off this lesson, we need to talk about how to round decimals. So I'm going to ask you to grab your blue one more time here for me. And we're going to make a box around these instructions. So we've learned rounding in a previous lesson. And when it comes to decimals, we really want to focus in on this kind of shortcut that we're going to look at. So the shortcut is every digit after the place being rounded becomes a 0. Every digit after the place being rounded to becomes a 0. So in decimal numbers, this basically looks like those digits are just chopped off. This will be the value if the number is rounded down. So step 2, we're going to increase that last digit of the rounded down number by 1. Increase that last digit by 1. So remember that if the last digit's a 9, increasing it would be 10. So when that happens, we'll actually end up with a 0, and then we're going to carry that 1 over into the next place value, just like we would in addition. So if you got a 10, you'd put a 0 and you'd carry over. So we'd carry. This will be the value if the number is rounded up. And then step 3, the first digit to become a 0, the first one to be chopped off, determines how the number rounds. So remember that in our number system, just like we have 10 fingers, and fingers are sometimes called digits, we have 10 digits in our number system. And so the smallest digit is 0, so if we have 0, 1, 2, 3, 4, the lower half of the digits, 0 through 4, will round down. The upper half, 5, 6, 7, 8, 9, so 5 through 9, round up. All right, so let's put this together then. So we're going to round these numbers to the nearest 10th. So if we're rounding to the nearest 10th, when you see 10th, you should be thinking, okay, 10th. Okay, so if this is a 10th, 1 0 in the denominator, remember, means 1 decimal place. So we're going to keep 1 decimal place. That means everything after it is getting chopped off. So 0.3 is what this will be if it rounds down. So that's step 1. Right there, that's step 1. Now, if this rounds up, we just increase that last digit by 1, so 0.3 becomes 0.4. So if it rounds down, it'll be 0.3. If it rounds up, it'll be 0.4. All right, so now, which one? Does it round up or does it round down? Well, it's the first digit to be chopped off. It's this 1 here that tells me up or down. And a 1 tells me to round down. So 0.31459 is approximately equal to, make sure that you're using that approximately equal to sign. If you use an actual equal sign, it is not technically completely right. Okay, so there may be some loss of points if we're not using the approximately equal to when we round. So, but it's approximately equal to 0.3 when rounded off to the nearest 10th. So if we come over to this next number, 0.981203, so to the nearest 10th means we're rounding to the nearest 1 decimal place. So we're going to keep the 9, but everything after it's getting chopped off. So this will be 0.9 if it rounds down, and then if we increase that by 1, then remember that 9, we're going to have a 0 here, and then the 1 will carry over. So 0 and 1 makes 1. So this is in between 0.9 and 1.0, which 1.0, of course, would just be 1. So it's the first number to get chopped off. It's the 8 that tells me to go up or down. And an 8 tells me to go up. So this would round off to approximately 1. And I would simplify that for my answer to just 1. All right, go ahead and pause the video at this time and try the next one for yourself, and then you can hit play again and we'll see how you did. All right, let's check out this last example here. So if I'm rounding off to 1 decimal place to the nearest 10th, then this will be 0.7 if it rounds down. It'll be 0.8 if it rounds up. It is the first digit to be chopped off, the 6 that tells me up or down, and a 6 tells me to go up. So 0.76543 is approximately equal to 0.8. Next row, if we round off to the nearest 100th, when you see 100th, you should be thinking that's like a fraction over 100. Okay, so if there are 2 zeros in the denominator, that means there are 2 decimal places. So we're rounding off to the second decimal place when we round off to the nearest hundredth. So that means that this time I'm going to keep these first 2 decimal places. I'm going to keep the 3 and the 1, and then everything after it's getting chopped off. So if this rounds down, this will be 0.31. And if it rounds up, remember we take the last digit and increase it by 1. So 0.31 will become 0.32. So this number is between 0.31 and 0.32. Which one is it closer to? Well, it's the first one that is after these, the first one to get chopped off that tells me up or down, and a 4 tells me to round down. So 0.31459 is approximately equal to 0.31. All right, so for the next one here, again, rounding to the nearest 2 decimal places. That means everything after it's getting chopped off. So if this rounds down, it'll be 0.98. And if it rounds up, it'll be 0.99. It's the first one after that gets chopped off. That tells me up or down. And a 1 tells me to go down. So 0.981203 is approximately equal to 0.98. And again, go ahead and pause the video, try this last one for yourself, and then let's see how you did. All right, so if we check this one out, we're going to keep these 2 decimal places, everything after it's getting chopped off. So 0.76 if it rounds down, increase that by the last digit by 1, 0.77 if it rounds up. The last digit, our first digit to be chopped off tells me up or down, and a 5 tells me to go up. So this 0.76543 is approximately equal to 0.77. And so finally, we want to round to the nearest cent. Okay, so when we're talking money here in the United States, cents is the lowest that we go. We don't have a fraction of a cent. So we should know that cents is 2 decimal places. So if we chop off everything after those 2 decimal places, so this is really the same as rounding to the nearest hundredth. So if we round that off, this will round down to $5.49. And now just go 1 penny more. So if you get 1 more penny, $5.50. Now, which one is it going to be? It's still the first one that gets chopped off that tells me up or down. So a 6 being the first thing chopped off tells me to round up. So this would be approximately $5.50. So $5.49623 would be approximately $5.50. So next example, again, near a cent, we're going to keep those 2 decimal places. So if this rounds down, it'll be $17.99, and then go 1 penny more. So if I go 1 penny more, that's going to spill over to $18. Now up or down, it's the first thing getting chopped off, the 1 here, that tells me to go down. So $17.9915 is approximately $17.99. And once again, go ahead and pause the video. Give this last one a try for yourselves. All right, let's see how you did. So near a cent, we're going to keep these 2 place values. Everything after it's getting chopped off. So if this rounds down, it'll be 45 cents. And so if it rounds up, it'll be 46 cents. The 3 is the first thing getting chopped off, and it tells me to round down. So $0.4532 is really 45 cents, approximately. And that, ladies and gentlemen, is the end of our lesson.